Hello and welcome to episode 16 of writing a 6502 assembler in assembly language. In the last installment, I wrote the code to look up symbols in the symbol table. It was actually a little bit of a rewrite. Episode 14, I wrote about half of it, and then I recorded it in episode 15 and the code that wrote the rest of it, and the code I did not like at all, so I basically just ditched it. And in the episode 15 that's in the playlist, I went ahead and deleted all that code and rewrote it in a much nicer way. And so the goal today is to make sure that code works, to test it out and see that it works. And if it does, we can move on to other things. There is one little error in the code that I wrote last time that I want to take a look at real quick, which is just an addressing mode error right here. I have the high byte of the address of a block allocated by the malloc subroutine in Y, and I tried to just store it here using an absolute address index with X. You can't do that. If you look at the 6502 instruction set, you can only do that with 0 page, not with absolute addresses, which is no big deal. It just means that right here I have to move the Y register to A, and then I can do that. So that's all we have to do to solve that little problem. And now let's get on and try to write some debugging code to see whether or not this works correctly. When I was looking at the code off screen, I did notice a few small problems. And first, that was in the malloc function or subroutine. A few small problems here. First off, we get the break, which is the location of our new thing. We then add 32 to the break. And then previously I had done a full 16-bit add. And then so the high byte of the new break was in A, but then I changed it to just increment the high byte if the carry is set. But that means that the high byte is no longer in A, so I can't do this comparison here. So we'll have to fix that. So I'll just have to load it in. All right, so load it. Now I can compare to the high byte. If the high byte of the new break is less than the high byte of IO above 0, then we're okay. That will go to malloc 0. Then I said, if it's greater than or equal to, go to malloc 1, which is a fatal error. That's not correct either. This needs to be branch of not equal. Okay, so what that would mean here is that the high byte of the break is not less than IO buff, and it's also not equal. That means it's greater. That's an error. Otherwise, if it's equal, we can go ahead and load the low byte, compare the low byte against the IO buff. That's the low byte of the new break location. That is, what's in the break variable here should be the byte just past the last byte of the allocated space. And if the low byte of that address, the new break location, is less than IO buff, then we're all good. If it's equal to IO buff, actually it's okay too, because that would just mean we've, remember that the new break location is the byte just past the last byte of our allocated space, so that would be okay if that's equal to IO buff. So if it's less, it's okay. And also, if it's equal, it's okay. But if it's greater than, if the new break location is greater than idle buff, then it's a problem. Okay, and then we store the old break location, that is the address of the memory of allocated, the 32 bytes there, here, so that we can zero it. Get a 31 into X, 0 into A, and zero this out. And then we retrieve our X, that is the low byte. So now we again have the address of the allocated memory in X and Y there. And then we return that. So that was a few mistakes I noticed there. And I noticed also a little mistake here in the lookup subroutine that we wrote last time, which was particularly just that when we go to the label lookup 3, right here, what this means is that we have found a space in the symbol table, an empty entry into which we have to copy the name which was read by the scanner. And that's what this loop does right here. It just copies that name in there. But it's important that when we come here that y is equal to 0, because we're going to take the 0th character and copy it, and the 1st character and copy it, and so on. And when we go to lookup 3 here, we have y is 0, so that's all great. But we also drop into lookup 3 from this place, which is when our hash value of our name pointed at a null entry in the symbol table, and so we had to start a new chain of symbols there. That's when we come here. So we just need to make sure that y is 0 before we drop into here. And then also here we have this situation. This is the situation where we already have a chain of symbol table entries coming off of the symbol table for a given hash value. But the symbol that we're looking for is not found in that chain, so we have to allocate a new block in that chain and tack it onto the end. And then after we do that, we'll go back up to lookup 3. Again, we just have to make sure that we have y equals 0 there before we go up here to copy the symbol into the newly allocated space. All right, so that's really the only problems I found there. And let's just remind ourselves of what happens when we find a symbol in the symbol table. Well, actually, whether we find it or not, because if we don't find it, we will insert the symbol into the symbol table, and then we will have found it in the symbol table. We're going to store the address of that symbol in the toke file variable, which is a 2-byte variable. Yes, at least I believe that's correct, the correct place to put a toke file. Well, we'll find out in just a second. So let's go, that was in the file AS1. Let's go back to file AS0. Okay, here, let's look for the place where we get a name. Okay, so here's in the scanner, and we've decided that we've got a character which could be the beginning of a name, or which is the beginning of a name, and so we jump to get name. And here it is. Here's the get name. All right, and of course it has to check for every character. It starts acquiring characters from the input, and for every character it has to see, is this the continuation of a name? And that's what all this stuff is. And if it's not, it will say, okay, I'm all done, which will go here. And what this does is it ungets the last character, which was not a continuation of the name. It was not a letter or a number or an underscore or a dot or something like that. and then it puts 0 in Tocqueville. All right, and then it gets an x, a value in x here, which is basically the index into the buffer at location hex 200, and it puts a 0 in that just to null terminate that thing. It jumps to is keyword to see if it's a keyword. Now, is keyword returns the token type in A and returns the, and if that token type is not name, well, is keyword will return either the token type TNAM, T name, token name, or it will return whatever other token it is. For example, it's a certain type of opcode. And if it is a name, that is to say it's not a keyword, then it returns 0 and Y. If it is a keyword, it's going to return some value in Y, which is used to figure out which type of opcode or keyword this is so we can handle it appropriately. Okay, so actually what we want to do here is we want to check and see if Y is 0 coming out of is keyword, then that means we actually have a name, and we need to look up that name using the lookup subroutine, which if the name is not already in the symbol table, it will go ahead and add it to the symbol table. So we can store Y in Tocqueville. That's all fine because it's just putting a 0 there, which, kind of technically we don't necessarily need this line here, but it's all right. It won't hurt anything to just leave it there for now. And now we'll compare Y to 0. If it's equal to 0, then we're done. And I'll just call it 9A. Oh, that's kind of long, isn't it? I'll call it probably get name 8, just to make it a little bit shorter. 8. Okay. So actually, sorry, we need to do here, if it's not equal to 0. So if Y is not equal to 0, then it was a keyword, and we're done. Otherwise, we need to JSR to lookup. And all that will do is either find the symbol in the table and return a pointer to it in Tocqueville, or it will add the symbol to the table and then return a pointer to the entry in Tocqueville. So just JSR lookup is good. We do need to make sure we still have tnam in A, which of course lookup uses A, so it wouldn't be there. So we just have to put that in there to make sure that we're returning token type name in A. Okay, so we're at 95% full for this file, so we have to be careful, but that looks good. And now, if we go up to the top of the file, we have our debugging code here, which prints out the tokens. Okay, we have scan and parse file, JSR PRToke. So we're going to print out the tokens. Here are the tokens. Right, these are the token types you get if you have a keyword. All right, let's look at the tokens. So if it's not a string, here's all the things we could get. Okay. compare x 128. Oh, I see. So if it's greater than or equal to 128, I'm guessing it must, yeah, it's a keyword. So it's going to print that out. Okay. So this is where it handles the keywords here. All right, and here's where it handles the name. Now, if it's a name, what it does right now, it loads 200, hex 200 into x and y and calls puts. We don't want to do that instead because that's 200 is the buffer that the scanner uses to collect the name. But actually what we want to do now is print out the name from the symbol table. So instead of doing this, we will do load x with tokeval and load y with tokeval plus 1. Because if it's a name, then it should have been looked up in the symbol table, and the pointer to this entry is in tokeval, and the very first thing in that pointer is the text of the symbol itself. So if we are successfully putting them in the symbol table and getting them back out, then this should print it out. Now, there is a very small little issue, which is that the symbols in the symbol table have up to 12 characters for the name, and it's not necessarily null terminated. That actually doesn't matter for now, because right after those 12 characters, here I can pull it up, right after those 12 characters is the type, and the type is going to always be 0 for now. So later on, this is just for debugging purposes, but for later on, we would not be able to use the put subroutine here, just in case you have a 12 character long symbol plus a type which is not 0. Type 0 probably is going to be undefined, so undefined symbol. So anything, if you ever had a symbol which was 12 characters long and was not undefined, then puts would fail miserably on this. But for the moment, it's fine, because for the moment, this type is definitely 0. So we're going to load that in and print it out. Okay, so I think now is the time to save that, exit, and to assemble it. Oh yeah, see, we're going to have all sorts of assembly problems because we haven't tried to assemble it since we wrote all of the symbol table stuff, so some sort of error there. Okay, so let's look here. What are the errors? Misplaced statement. Okay. So it looks like it's upset about something not being in a proper code segment. So let's just get rid of that. Go here and say, this actually probably shouldn't be segment utils, it should be segment names or something like that, but whatever. So we're going to search for SimComp. Oh, I see the problem is. The problem is this end means the end of the code segment. So we have to do that. And put a new end down here. Okay, so as far as it was concerned, the code segment was over, but we had a bunch of code after that, which is, as it thinks, not so great. I'll just call that segment names because it's not really utils. It's about whether or not this whole file is pretty much about whether something that looks like a name is a keyword or not. And if it's a keyword, you have to tell which keyword it is, and if it's a symbol, this is not a keyword, we have to put it in the symbol table. So that's pretty much this whole file here. All right, and just real quick, I'm going to make sure that's the only end in there. Oh, I got another one there. I better get rid of that, otherwise it's going to be more trouble. All right, that looks good. One more time. Okay, that's just indiff. Okay, good. All right, let's try it again. Just go ahead and send it to the printer, just to be sure. One error found. Oh yeah, missing operating on ASL. That dumb old thing. Okay. Yeah, personally, I just don't see why it's so important that we have to have ASLA, but I mean, I don't have any problem with ASLA, but it seems like it ought to work just fine without it, because typically, if in the 6502, if you don't have an operand for an opcode, either the registers used are in the opcode itself, like right here, or they're just, you know, it means A. So, well, whatever, ASLA. Okay, a link error of some sort. We'll just take a look at that. All right, what do we find? Unresolved reference tokefile. All right, so that means basically somewhere here, this is in file AS0, we have our variable tokefile, and this variable is not globally accessible. All right, well, maybe I'm not going to search for it that way, because it's a pain in the butt. It's down here somewhere. Here it is, tokefile. Okay, like I said, I'm going to fake out the assembler the same way I did last time by calling it an entry point, which it definitely is not, but it'll make it a global symbol for us. Okay. Just in case. Send it to the printer. All right, everything looks good. Okay, so now we will try it, and I think, yeah, that's right, I had the file called test. Just take a quick look at that. Okay. All right, that looks fine. And we'll have to send that to the printer, of course. Oh no! A wonderful crash. And nothing here. Okay. Well, that's the kind of error I don't like to see, because it's a pain in the butt to fix. First off, we have to reboot. Restart the Orca command line. Set our current directory. And here we are again. So, a crash like that is usually the result of the stack getting screwed up somehow. Well, I think the first thing to do, actually, the first thing to do now is go back here to AS0 and see where we call the lookup subroutine. Okay, and get rid of that. So let's take that out. Okay. And then let's go down here. Here we go. Take this out and put back what we had before. All right, so we're not calling lookup, and we're going to print out the name, if we have one, based on the scanner's buffer, not based on the symbol table. Okay, see, that's nice. Okay, well, it's partly nice because now it's not finding the keywords again, but I think that's just a very simple issue here. It's related to this place time here. So we look for a keyword. We store y in toke file, compare y to 0. If it's not equal to 0, go here. Well, let's, for the moment, let's just comment all this stuff out because that's the way it was before. Right? We would jump to keyword and then store y toke file, and that was it. That was that. But it's still not finding the keywords. This is like, I would say, super annoying. Like, I didn't change anything here, I'm pretty sure. Well, in order not to bore everyone to tears, I'm going to stop recording and redo this code and try to figure out what's going on. I won't fix it without coming back though. So just a minute. Okay, that was depressingly stupid. It only took me about 5 minutes to find the problem, I think. And I just really don't know how it happened because we had this working back in episode, I don't know what, 12 or 13. And somehow it got changed and I don't remember changing it. So anyway, the issue here is that in key comp, we're going to load x with 0 because we're going to step through the name read by the scanner, and we get the first character of the name read by the scanner. We remember that in y because we're going to possibly or this bit in there because that will change uppercase to lowercase, and the goal is that we want this to be case insensitive. So we put the original thing in y. We say, okay, if that was a null, then we're going to skip. We're not going to OR this thing in there because we only want to OR in there this bit if the character is not a null. We can't do it on that null at the end of the string. If we do that, then we're going to be that'll change it to a space, and we'll be trying to compare a space with a null, and it won't work. So anyway, if the character we just looked at is not the null, if it is the null, we skip this. If it's not the null, we OR this in here to change uppercase to lowercase. It doesn't affect digits or anything like that. Then we do this subtraction to compare the two. If they're not equal, then that means the two strings we're comparing are not equal. So we go down here to exit. If they were equal, and we now see, hey, was that thing we just compared to the null character at the end of the string? That's what this is right here. And if they are, then we leave. We say, okay, we've compared everything, including the null character, and they all match, so it's a match. So we'll go down here and leave. Otherwise, we'll increment x to get the next, to check the next character of the strings. But then we go right up here, which makes no sense at all, because we need to go up here to get the next character of the string read by the scanner. And I think what happened is that originally there was a label here, key comp 0, and this label here, key comp 0, would go up there. And then I added this label here to get around this, back when we had a problem originally that we were ORing in even when it was the null byte. So that turned the null into a space, and then space doesn't match null, so it didn't match. And somehow I got rid of this one, which I really don't understand. And I thought it was all working, but the solution is pretty simple. We'll just put in key comp 3 here, and then change this to key comp 3. So now key comp 0 is a label used to not OR in this bit here, the 20 bit. And key comp 3 is the top of the loop where we get another character. And that should do it. Okay, and yes, now the keywords are being recognized again. That's why these things here are hexadecimal values, because the hexadecimal value tells you basically which type of opcode it is. Okay. So now we're ready to go back and look and see why the thing was crashing before, why we had a crash. And let me just go back here for a second. Let's look for is keyword. Okay, so is keyword. Okay, if it's all right, so these still need to be commented out, because what's going on here, well, what we could do is, as a temporary issue, a temporary matter here, we're saying that if y is not equal to 0, it's a keyword. So this is not a keyword, it's a name. Let's just go ahead and load the address of the scanner's buffer, that is 200 hex, and put that in Tocqueville. Remember, this lookup, the lookup subroutine is supposed to put the address of the symbol table entry in Tocqueville. But I'm going to put this here just for now, and this is not supposed to be 20, it's supposed to be 02. And the reason for that is that I can now go up here and get rid of this, because this is what I really want anyway. I want to get the address of the string to print from Tocqueville. Okay, that all looks nice. No, it doesn't, because it's not printing out these symbols here. what's going on there. Okay, this is clearing Tocqueville. Okay, looking for a keyword. Compare y to 0. If it's not 0, go down here. That's a keyword. Oh, let's put this here. Why does that not work? 2 cross plus 1. It seems like that ought to work. Okay, my guess is that for some reason I'm not coming here. But I should be. All right, let's just try putting a string here. Okay, so it does print out here, 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 which means it got to that piece of code. Which means it should be loading 0200 into Tocqueville and returning. Oh, I know why. Okay. The reason is because the token tnam is in A, and we just destroyed it by doing this here. So I just don't use A, use X. That'll be fine. Okay, good. Now that those are all there like they should be, so now the really thing is lookup is crashing, and we need to figure out why lookup is crashing. So again, I'm going to go off screen and just look over the code rather than bore you by spending 10 or 15 minutes silently reading the code. So I will be back in a minute if I find something. Okay, I'm back, and I have found two issues. The first is here. In the symbol compare subroutine, I'm getting a character from the name scanned by the scanner, and I'm pushing onto the stack so that I can later see if it was a null. But this doesn't work because if I push onto the stack here, but then the comparison is false here, I just go down to here and then try to return with some garbage on the stack. I can fix this by, instead of trying to push onto the stack, just put it into the A register, into the X register, sorry. So move that into the X register, then move the X register back here. That should solve that problem. And then I noticed also that at lookup 2, this label is where I have a block in my linked list. That is, I have something like this. And first I check this one to see if this matches the name that the scanner has found. If it does not, I check this one to see if this matches the name that the scanner has found. If it does not, then I copy this pointer into my 0 page locations 50 and 51, which means I loop back to the top of that part of the subroutine to check then the next block. And that loop is horribly wrong. Here's where I check the first one, right there. Here's where I check the second one. And I look and see if there is an available space for the symbol in the block. For example, if this is all zeros here. If this were all zeros, I could fill in this space. That's what I'm looking for right here. If it's all zeros, I can go to lookup 3, which will enter it into the block. If it is not, then I'm going to go ahead and get 16 and Y. The pointer at 50 and 51 is pointing basically like here. Plus 15 will be this byte, plus 16 is this byte, so it's the high byte of this. When Y is 16, we get the high byte of this link pointer. And if that's 0, then there's a null. So that means I need to allocate a new block. If it's not 0, then I first off just save that high byte in X. I get the low byte. I store the low byte and high byte in my 0 page pointer. But then I jump to simcomp2, which is horribly wrong. That would mean I'm jumping up here, which would then, of course, do an RTS and bomb out immediately. So this should not be simcomp2. This should be lookup2. In other words, I want to go here. This is where I want to go. Now that I've updated my 0 page pointer in locations 50 and 51, I want to go back up here to check this new block, whether or not it has the symbol I'm looking for in it. All right, so let's save and exit that. Assemble it. I didn't see any errors. Just check to be sure. Yeah, no errors. All right, and now, no crash, but an infinite loop. So again, I have to reboot, and didn't get any output here. So now I have to go figure out what's causing that infinite loop. But I've solved the crash. So again, I'm going to look at it off screen and come back so as not to bore you to tears. Because what if it takes me 40 minutes to find that problem? Well, you probably don't want to watch that. So I'll be back in a minute. Okay, I'm back. And what I've just done is I added this code here. So in the lookup, I just wanted to see, okay, when it very first hashes the symbol or the name from the scanner, I want to print out what it sees. So it's going to just print a T, then it will get the offset into the symbol table, which is X here, prints that out, prints a colon, then it gets the value from the symbol table, which should all be nulls originally, and prints that out, high byte, low byte, then a new line, and then it restores the X here so it can continue on down here. So I did this, and I've already run it, but I'm just going to do it again just to show you guys. So when I compile it, print that out, and an infinite loop as before. So I'll just do a reset. And then here, I got 1 before I entered the infinite loop, which is that it has a x value of C6. And at symtab plus C6, it finds this address here. But C6 is not a valid entry in the symbol table. That's not allowed. What I'm trying to do is my symbol table has only 64 entries, numbered from 0 to 63. And therefore the offset should be double that, from 0 to 126. And C6, if we pull up the calculator, all right, so C6 is 198, which is more than 126. So that should never happen. So I went back and looked carefully at the code that was creating the hash value to see what's going on there, because it's creating a hash value which is not allowed. It's outside the symbol table. So if we go in there and look at this again, all right, here's where it's attempting to, so it creates the hash value, the hash of the symbol by adding up all of the characters in the symbol until it gets to 0. And then it's ending with 63, but I notice this is the big mistake. It's ending hexadecimal 63, which is not at all what I want. I want the end here to be decimal 63. So decimal 63, if we look, it's 3F in hexadecimal, and that means this is 111111. So all of those low bits will be preserved. Everything above that will be thrown away. So for example, if we have 126, which is valid, right? And then we end that, let me go ahead and switch here, 70, and we end that with 3F. I'm sorry, 126 is not valid. 63 is the highest valid X before we shift it to the left. So, right, 63 is 3F, and 3F just gives us 3F again. All right, if the hash, when we added up all the characters in the symbol, it happened to be like 157 or something, then that would be ANDed with 3F. And so it would hash to 29, which would then shift it up, and so it'd be the offset would be 58 in the symbol table. But we were hashing with hexadecimal 63, not 63, which is 99. That's not useful at all. That's not what we want to do. So basically, we just have to change this to 63, not hexadecimal 63. All right, and save that. Okay, it ends with no infinite loop, and it's got a lot of output. Every time it looks it up here, it's saying, okay, I have the hash, I'm hashing to offset 6E, that's a null, that looks nice. Here I'm hashing to offset 3,4, that's a null, good. Offset 2,6 is a null. Offset 3,8 is a null. They all should be nulls, of course. Oh, here's others. 5C is a null. Oh, here it hashed to 5C a second time. So I guess it's this in error symbol hashed to 5C, offset 5C. There's a null, so it allocated space, and then Tocqueville also hashed to 5C. So now it's got a pointer there, a pointer to that memory space, the 32 bytes that was mallocked. Okay. Yeah, I'm not 100% sure what's hashing to 5C here. Maybe does dot hash to 5C? So in error hashes to 5C, dot hashes to offset 5C, I guess so. Tocqueville hashes to element or offset of 5c. Dot again hashes to 5c. All right, that's interesting. Dot is actually going to end up being special, and we don't necessarily need to have it hashed to anything in the symbol table. We'll just check for it later because that's a special name. But lines, that seems odd that so many things would hash to 5c. Tocqueville lines, but okay, 12, 4, 4. Anyway, it looks kind of like it's working here. Here, this one hashes to 0, which I guess is probably IO error, or maybe it's hex error. Oh, yeah. Actually, I think this gets printed before. So actually, it's just dot. Dot hashes to 5c. N error hashes to offset 3, 4. Dot hashes to 5c. Dot hashes to 5c. Oh, it's all these dots. They're all hashing to 5c. Okay, that's fine. That's no big deal. All right, I was worried there for a second, but no, actually, it's just dot that hashes to 5c. And actually, like I said, dot is going to be handled specially. So here's a case where we have a real thing. Hex error hashes to 2, 0. And then CC error also hashes to 2, 0. So we've allocated something there. This one's allocated 3140. This one's allocated 31E0. That seems a little bit odd. Something should have been allocated at 3160. And then 3180. And then 31A0, C0, D, E0. Wow, I certainly hope it's not allocating an extra thing for every dot here. That would be a problem. But it looks like it might be doing that because 31E0. Now the next time it has something it's allocated at 3260. So yeah, it looks to me like something's not quite right with how it's allocating the memory, because if this is the first thing allocated at 3140, the next thing allocated should be at 3160. And these are all the same thing, dot over and over again. So anyway, there's some sort of problem here that's yet to be fixed, but at least we don't have an infinite loop now. So solve that little problem. And now the goal is to go in and figure out what's going on here. Why is this 3140 and then this one is 31E0 when it probably shouldn't be? So again, I'm going to take a little look at things off screen and then come back when I have something to show you. Okay, actually I'm back right away. I didn't actually do anything except for just reload the file. I'm going to get rid of this debugging code I put in there. And I think what I'm going to do now is I'm just going to go up to the malloc subroutine, and every time I allocate memory, I'm going to go ahead and print out the address of the memory I allocated. And that should allow me to have some idea of what's going on here. Okay, so this is where I come when I've allocated the memory. And then I clear it to all zeros. Okay, and I put the place I stored there. So actually everything looks great. I can just go here and print out the data I want to print out. So for example, I can puts, all right, and then this should be the high byte of the allocated address of the allocated memory. This is the low byte. and then a new line. And now I have to reload x and y for malloc to actually make any sense. Okay, so it'll return these things here. And I just printed a string up there, so I have to make this string, this debugging string. There we go. So it'll print out malloc and print out the address of the allocated memory, and then return the allocated memory. All right, let's see. So malloc 3100, malloc 3120, malloc 3140, malloc 3160, malloc 3180. Okay, yeah, actually, now I see that what I was thinking last time is slightly wrong. Every time it goes to look up a symbol and hashes it, and then that value in the vector, like this here, is a null, it has to allocate a block. So that's actually not so bad. I'm not sure why it's allocating a block here, though, because... well, right now it's treating .bss as a symbol, it looks like, but actually it's supposed to be a keyword. So I remember before I was paying close attention to these opcodes and making sure they showed up as keywords, but BSS should also be a keyword. So I guess it's allocating, it thinks BSS is a symbol, it's allocating something for that. And it thinks that in error is a symbol, and it's allocating for something for that, which is fine. It's allocating for dot, which it probably shouldn't do because that's going to be special. It's allocating for Tocqueville, it's allocating for lines, for dot data, which also should be a keyword. It's allocating for IO error, for hex error, for chur error. Now this, it doesn't need to allocate here because remember this had the same hash value as hex error. So we don't see it there, that's nice. Okay, it's allocating for stir error, it's allocating for Toctab, it's allocating for esktab, and then so on. Get C, it doesn't allocate for. I'm assuming that it's okay. Peak C, it's allocating for get C4, and for IB count. All right, I don't know what this malloc is for. Oh, FD is a symbol. Okay, read for nbuff. Malloc for fatal. Okay, that all doesn't look so bad. I don't know exactly why it's not allocating for get C. It must be that it happens to come in here where there's already a, it goes into one of these other buckets, I'm going to guess. So actually, that doesn't look too bad. And I just wanted, these things should be keywords, .bss and .data, and well, dot also, I suppose. So we're getting there. The actual symbol table stuff just might be working correctly. So the things I need to do now is I need to make sure that these are returned as a keyword of some sort and not as a symbol. The things .bss and .data and just dot by itself. And I also, after that, I probably will go back and just write some code to dump the entire symbol table, just so I can look at it and make sure that it seems to be correct. Okay, but I will stop that. And I think the time is probably enough, so probably we will continue in the next episode. Until then.